Hi, and welcome to the chapter 3 of Prep Maths. And today we're going to revise the equations. So, chapter 3 is dedicated to equations and one unknown, where we will cover transformations and solutions, linear and quadratic equations. Also, at the end, we will talk about radical, absolute value equations and substitution. So in this chapter, we will look more in details to different types of equations and ways how to solve them. So we will start by revising equations, transformations, and basic solutions. An equation is a statement that shows that two mathematical expressions are equal. For example, 3x plus 12 equals to 4. This is an example of an equation. For equations, the following operations are equivalence transformation. First one is swapping sides. Small remark, this sign here is equivalence mark. For example, we can swap sides from this equation. So if it's 3x plus 12 is 4, and we can rewrite it as 4 equals to 3x plus 12. So the next equivalence transformation is adding or subtracting the same value from both sides. For example, if we take our major equation here, and again, we decide to subtract 3 from both sides. So it will be equivalent to the following equation. So we can just rewrite it 3x plus 12 minus 3 is equals to 4 minus 3. Then we get the new equation, which is 3x plus 9 equals 1. So both equations are called equivalent. So the root of this equation will be the same. The third transformation is multiplying or dividing both sides of an equation by a non-zero number. Same, we take our equation 3x plus 12 equals 4, and we decided to divide it by 3. Both sides. This is very important, both sides. So this side and this side as well. So it will look like following. 3x divided by 3 plus 12 divided by 3 equals to 4 divided by 3. In other words, we will have equation x plus 4 equals to 4/3. So these are the major equivalence transformations, but very important, taking power or taking roots and squaring an equation are not equivalent transformations. So if you take power for both sides or you want to take a root from both sides, it's not equivalent. I hope everything is clear here. We can move to the next part. So many equations have multiple solutions, no solutions, or even infinitely many solutions. For that reason, it's useful to speak of the solution set of an equation. So the set of all solutions of an equation will be denoted with letter L and called the solution set. So let's not concentrate on how to find solutions. I will just give you an example what kind of solution we can have and just talk about solution sets. How to solve equations, we will talk about it later. Now we just want to talk what kind of solution sets we could have. So for example, for an equation 3x minus 15 equals to 0, x0 will be equal to 5, and it's the only solution. And this will be the solution, and there's only one solution. So the solution set will be L equal to 5. You remember we write sets in curly brackets. It's one way to write them, and we had it in the very first chapter. So, next one. The equation x squared equals minus 1 has no real solution, and hence there is a solution set is empty. And if you remember, we can also write an empty set with this sign here, and so the solution set for this equation will be L equals to empty set. So there is no solution, no real solution. Yeah, this is very important, no real solution. We take another example of x squared equals 4. And this equation has two solutions. So, namely x1 and x2. Or some also say, can name it x plus or x minus. Same. So, it will be 2 and minus 2. So the solution set of this equation will include minus 2 and 2. So there is also different type of equations. For example, sinus x equals to 0. And this equation will have infinitely many solutions, namely all integer multiples of p. So solution set will have infinite number of solutions. So we can write it like this. So basically that's it for the solution set. This was a short introduction of solution sets, what kind of solution sets we can have in the equation, and how we can write them down. So, and now we will go to the next topic, which is directly connected with solving the problems. And we are moving to the next topic, which is linear and quadratic equations. So we will start with linear equations. An equation of this form, bx plus c equals 0, where b is non-negative number and b and c is a real numbers, is called a linear equation or linear equation in X. The linear equation can be solved by using equivalence transformations. For example, if we just take this general form and write bx plus c equals 0, so c is a number here. So we want to subtract c from both sides. So in this case, we will have bx is equal to minus c. And then we can also divide this to b. And in the end, we will have x equal minus c divided by b. So we can see immediately that linear equations always have unique solution. So the solution set in this case will be minus c divided by b. So it could be not very intuitive with the letters, but let's solve it with like a normal equation with the numbers. So let's say 6x minus 12 equals 0. We can subtract minus 12 from both sides of the equation. And in this case, we will have 6x equal to plus 12. If 6x is equals to 12, and then to find 1x, we will have to divide both sides on 6. So it will be 2. We can solve it like this one by one, or just immediately see in normal form. If it's like given in normal linear equation, you can just know that x will be minus, so c here is minus 12 divided by 6 directly, so, and it also equals to 2. So the solution set for our example will be 2. So linear equations is quite easy to solve. And next we're going to see solutions for the quadratic equations, which gets a bit more tricky.